Hello, everybody. Good morning or good afternoon, and thanks for joining to this webinar of Land Design for AutoCAD. Land Design is a BIM landscape design software, works as a plugin in AutoCAD environments, and we'll see first a general overview of the program, and then we will see during the live demo how to develop a project. So the program helps us to have 2D drawing. The 2D drawing link is linked to 3D model. It automatically generates the list of plants, walls, zones, and furniture, and terrain operations as well. And then there are tools for animation and visualization of the project. Um, it is a BIM program, building information modeling program. So the objects are smart objects. The program already knows this is not just a block, this is a plant of that species with that size and with that age and all information. The 2D and 3D are linked together, so whatever change that we do in 2D environment, it automatically applies in 3D as well. We obtain the list of quantification of the material automatically, and we can collaborate with other BIM programs during the BIM environment. Land Design as a landscape design plugin has two versions, one for AutoCAD and Civil 3D. So it works on top of AutoCAD or Civil 3D, and another version works on top of Rhino. So you either need to have AutoCAD or Civil 3D, or you need to have a Rhino installed in order to work with the program. In case that you don't have any AutoCAD or Rhino, another solution that we develop here at Asuni is the Rhino Lands, which is the standalone program. So it is Rhino plus Lands designed together called Rhino Lands, and includes Rhino with a simplified interface. Uh, well, the program is used for landscape architecture, but also in designing green infrastructure, in urban planning projects, and in environmental projects. For example, we can model a forest by using the program. So let's see the main features of the program. It is 2D and 3D linked together. So where you see this kind of blocks in 2D, when you switch to 3D, you will see that these blocks indeed are 3D blocks. So you find them in this form in AutoCAD. And whenever you apply a render, you will see that these blocks converts to another type of realistic blocks with all textures and all realistic details of plants. Okay. But we have an extensive plant library that it includes more than 8,000 plant species. The plant library also includes several filters to help us to select the adequate plant based on climate type, soil type, other parameters like plant type, flowering color, and so on. And as you see, any plant species has several blocks that are going to be used in different view modes. And this is the realistic model that will appear when you shot a render. We have dynamic documentation tools that help us to achieve the list of materials and also to add smart labels, for example, the plant labels, including the initials or the full name of plant species. We can add the image of plants with a specific command inside the program. We can select among the pictures and produce this kind of documentation. We can also produce different types of plans, dimension plans, and details, and all kind of documentation by its specific tools or with the generic tools of AutoCAD. We can produce also different sections and views of the same project and finalize our documentation stage. We have auto-generated schedules. So as you see here, this is by one click, we get the fence list, the plant list, the wall list. If we have irrigation system designed, so we can get the list of sprinklers, pipes, automatically calculated, and also furniture and terrain operation as well. We have parametric hardscape tools that help us to have parametric walls and edging, as you see in this image, parametric paths. So there are pathways, parametric ramp, and parametric stairs, and parametric fence. Also, there is a block library of furniture inside the program that we can import this kind of furniture from that block library. Of course, we can also import other blocks that are compatible, including SketchUp blocks, for example. Let's take a look at the hardscape tools. As you see here, we can produce this kind of ramps or stairs, and whatever change that we do in 3D or in 2D, we can see that it's applying at the same moment in 2D or vice versa. For terrain operation, we have this tool that help us to generate any kind of topographic contours to a 3D terrain. Or we can look for the location on the map and the program automatically generates a 3D terrain. Once the terrain is generated, there are tools for creating cut and fills, creating paths, and this kind of earth moving operation. The program calculates volume of all of this kind of earth moving operations one by one. In continue, we can add walls and hardscape objects like what you can see in this video. All of them are parametric, so you can change the distancing, the height, and this kind of dimension and material as well. We add stairs or ramps to this project. And let's see, in continue, we can add the furniture from the block library. So we can take a look at the block library included in the program. But as I mentioned, we can also import from other sources. In continue, we can insert some plants from plant library of the program. So yeah, by writing down the name of plant species, the scientific name or the Latin name, or by filtering the plant database based on criteria that we want. There are different tools and formats for plant arrangement. We can insert a row of plant or a group of plants, as you see here, and we can change the matrix or the arrangement of plants as we want. If we switch to 2D, we can add this kind of labels and information to the plan. So these are smart labels, as we saw before. So we can add the image as well and insert the list of materials and plants by one click. In 3D, we can change from winter to summer or to spring and see how would be the plants in different season. The interface that you see here, it belongs to Rhino. In AutoCAD, the interface is quite different, but the function is the same. So the program, the plants inside the program have this kind of seasonal change so that you can see when you apply a render. So the workflow is we need to start from drawing. So we need to start from Rhino or AutoCAD or Civil 3D to have a drawing, a basic drawing. Then in continue, we do modeling inside the program. So we add elements as we saw here. In continue, for visualization, we apply a render which is compatible to our platform. In the case of AutoCAD, we need to have a rendering tool that is compatible to AutoCAD, especially, I guess, I think Lumion is the best. And for documentation, we can export the data to Excel or to PDF or print drawings directly from the program. We can have collaboration with other programs like Revit, SketchUp, or 3D Max. We can import or export models from them. And if we have geographic information system files, GIS files, or DEM files, digital elevation models, point clouds, we can also open them inside Lands Design and do different types of terrain modeling or operation on top of this kind of files. So we can do the whole project inside the program. We can produce different types of plans, as you see here, by turning on and off the layers. And the realistic 3D, which when you apply a render, you will get a more realistic one. You can also produce this kind of sections. So in summary, the program is available for Rhino, AutoCAD, and Civil 3D. So you need to have one of these platforms in advance. There's a 60-day free trial, so feel free to try it out by yourself. and leave us your feedback, of course. The licenses are permanent, so it's just one payment forever. You will have free technical support from our team, so it's unlimited, and feel free to contact us for any issue later on. And there are educational and lab licenses for students, teachers at schools at a very, very reduced price. So if that's your case, you can enjoy this offer as well. Up to now, I don't know if there's any question or we can continue with the live demo.
All right. So thank you, Elham. Now we'll see some of the features that Elham has presented us through this live demo in AutoCAD, in Land Design for AutoCAD version. First of all, I will just work on a existing project. These are just a few 2D lines, okay, a few 2D lines that you would, create with the standard AutoCAD 2D tools. Actually, if we visualize this in 3D, we can see that they are all in the same plane. Okay, they're just a 2D drawing. And well, so first of all, we can see here that once we install Land Design, we have this ribbon with all the tools for developing a landscape project. These tools are divided into different topics. For example, we can find here all the tools to insert plans in different ways, individually in a pane mode, from points, from blocks, arranged in rows, forests, wraps, ground covers, okay, topiary also. We can find here the 3D modeling tools for civil work elements. Okay, they are parametric objects. We can edit them through parameters very, very quickly. There is a nice library of furniture blocks or for urban blocks that we can quickly select and insert into the model. Here we can find all the terrain modeling tools from importing terrains from GIS data or earth scanning, then files as well to create terrains or operations on these existing terrains. We will see some of these tools in a second. We can find some 2D irrigation tools. The 2D documentation, basically commands to list the elements that we have in the model, from plans to walls, zones, terrain, earth movement, and so on. We'll see also some of these listing tools. And some other documentation tools for dimensioning the plans, create areas of the project, and level marks, slopes. Okay, we will see some of these features too. Okay, and finally some additional tools. And then we have the edit panel. Okay, this is something that when we start a new project is empty, but as soon as we insert some landscape elements, such as a tree, we'll see this populated with information that we can edit or properties of the object that we select. We'll see that in a second. First of all, you also may see this floating toolbar. This is actually, a floating toolbar where we have the same commands as we have here. I will close this by now. If you want to recover this, just go to the menu. Okay, if you don't have the menu visible, you will be able to show it from here, from this little arrow. But now here we can go to Tools, go to Toolbar, and select Land Design to get this floating toolbar back. Okay, but since we have all the commands available here, I will just close it in this moment. Now, let's start by inserting a plant, which is maybe the most exciting thing in the program to see all the plant library and the different representation modes of the plants. So when you run the plant command, this dialog appears. We need to select a species from the plant database. And here, as we have seen in this presentation, we can find all the characteristics, all the different details that will help us search for one specific species. Okay, we can actually type the name here, and the list will update with all the species that match with the selected criteria. Okay, so there are several filters by which we can search specific species. Actually, here we can see in the header of this dialog the number of species that match with our criteria. Actually, I'm showing now all the plants that have a 3D render block assigned. But if you select all, you will see that there are over 8,000 species in the plant database. If you're searching for some specific species that is missing, you can actually create it from scratch. Okay, you can click on this button to create a new species, or you can just select an existing one and just make a copy of it and just modify the copy, to start from this species as a template and develop it further. Okay, actually, if we select any of these plants and we check the properties, just notice that each plant has a different representation modes in 2D, but in 3D there are different levels of detail, and we can assign different blocks for these levels of details to each species. Okay, here, if we click on this edit button, we will be able to change from all these values, the morphology, characteristics, and so on. But also under the display tab, we will be able to assign a different 2D crown. There is a folder with many options for the 2D crown. Actually, you can also develop your own 2D crown and assign it into these folders to have it available for your new species or for the 2D representation of any species. And same for the conceptual shape, for the detailed shape. And also here we can select a specific block that is a smart block that can have different representation modes assigned to seasons. So each one of these realistic representations can be displayed in different ways with different textures, flowers, colors of the leaves, depending on the season that in which we want to render the scene. Okay, so you can also select any of these species. Even you can develop a new file with a plant editor that is available with the program. Or there are two versions of this plant editor, but both are available if you want to create your own 3D realistic representation from scratch. Okay. Now let's insert this species. That's fine. We'll select it. Actually, here we will be able to see all the species that we have been selected. We have been selecting in each document. We define the size of the plant, approximate height. Also, this natural variation will make that all the items of this plant will be slightly different from another in terms of size. Also, random rotation will make it look different in 3D. And when you're done, you click OK. We just add a few clicks to insert the plants in our model. Okay. I will just move this into the area. Just notice that the boundary of these plants just merge. This is something that you can select in the edit panel when you select species. So you can just you need to actually select the edit plant option, and then here select the merge crown or not. Okay, this will have one single contour when two plants meet into it. And also we have the option to show or not the hatches. Okay, filling this to the crown. We can see here the different display options, not only in 2D, which is what we are seeing now, from setting out symbols to 2D count. But if we see this model in 3D, let's go from this button and we click on the 3D representation, we will see the plants in 3D. Okay. And here we can switch the different representation modes. There is these elevations, conceptual shapes. I will just switch to realistic, maybe detailed, and finally realistic. Okay, basically this realistic will be the best option if you need to show the render of the scene once the project is finished, because this plant will be replaced by a even better 3D representation of the plant, a realistic one. Okay, so this will provide us the option to produce nice renders. Actually, here in the document, we would select which is you see the season in which you want to select to render the scene, and then the plant will show, will be displayed in one way or another. Okay, so now I can just go to the viewport. I'm gonna work in 2D, and we'll use this 2D representation. Before we insert more species, I would like to show you how to define the areas of the project. So I already have here a few boundary curves. And first of all, I will create zones from these boundaries. And I will use the zonify command for that. Okay, basically this command lets you pick a point inside an area, for example, this one, and just give it a name. I will call this circulation. Assign a hatch pattern for this 2D representation. I will select a solid hatch, maybe with a different color. Mm, this one. And finally, can insert the label with the name and the area of this zone. Okay. I can do this by picking a point, an inner point inside an area that will detect all the boundary curves, but I can also select a boundary curve. So if I run the zonify command, now in this case, I will select this boundaries option in the command line. I can select, for example, this curve, and I can call this in a different way, like playground. Okay. I also select maybe a different hatch pattern for this and insert the label here. Okay. And if you want to group two zones together, for example, I have these circular areas were meant to be like plant pots. I can run this command, zonify command, and now after selecting boundaries, I will select the two curves at the same time. I will call this plant pots. Okay, I will select a different hatch, and finally the level somewhere. And I will do the same for these areas that I will populate with ground covers later on. So I run again the zonify command, again boundaries, and I will call this ground cover. In this case, I will select a different hatch, for example, this grass pattern in green color. Cool. So I have a little bit all the zones of the main area created. If you want to edit any of these zones, just need to select it. And from the edit panel, you will be able to change, for example, the scale of this pattern, change the name of the label, and so on. Okay. So from the edit panel, you are able to edit apply changes of anything that you have inserted into the model. For example, this plant, we can select it and change the size of it, change the species, for example, select another species from the library, like this one. Okay. Now, since we have created a few zones, maybe we can list already the zones. So here under the listing tools, we have the option to create a zone list. And this is a list that is linked with the zones in the model. So when we add new zones or we modify the existing ones, this list will update automatically. Actually, we can select this list. Here we can also enable this index or the sample icon to identify, each zone by its pattern. And if we select this list, we can also see some options like the option to export it to Excel. Or here we can define the borders and some some appearance details. Okay. But let's move on. Let's create some terrain here so we can explore the terrain modeling tools, which are some of the most important, powerful features in the program. We have seen already that I have a few lines here. They are all in the zero elevation. And the first thing that you need to do, I will use these curves to produce a terrain, but I need to elevate them into the desired elevation. Okay. These curves are meant to be like contours that are separated into an interval and regular intervals, but they could be curves totally messed up in the 3D model space. Even we could create terrains from curves and points And the program will take all these values of the points of the curves and the individual points and will generate a topography out of this information. But first, we need to elevate this. We could do this one by one, but of course, we have a better option for that, which is to use this tool, elevate curves, to elevate them all at once. I basically need to define start dimension, an increment, and then draw a line, and all the curves that intersect with this line, let me just repeat this, but with the oscillators off. All the curves that intersect with this line will be elevated according to this interval. Okay, maybe 1 meter is too steep, so I will just set 25 centimeters. And when you're ready, you close this dialog, and now we have the curves in the desired elevation, right? Cool. Now I will select by the way, I forgot to mention that the zones, when they are displayed in 3D representation, they are represented as textured surfaces. So for example, in this case, for the plant pots and the ground covers, we could change the material by another one that is provided by the program in a texture library. Okay, we can find here, for example, some materials for grass, some textures. And maybe the circulation area could be another kind of material. And go to site. Also, we can select this material. Cool. Actually, this one is not the one that I assigned before, so let me select this and select that grass. All right, let's move on with the terrain. Now we are ready to create a terrain from these elevated curves. So we'll select the terrain command, select all these curves, right, and hit enter. Now the insert dialog appears. We need to define the cell size of this terrain because actually the result is a mesh. So the smaller this cell size is, the more accurate it would be, the terrain will be with the input data. Also here we can also change the default contour interval, the material of the terrain as well, something that we can change. But I will just accept the default insert options and see the result, which is quite nice. Actually, all the curves that I used to create the terrains are actually in a hidden layer, in a layer that I can hide. So we don't need these curves anymore. And if we select the terrain, we can appreciate that it has observed the control points of the curves that I used to generate it. And if I move, for example, these curves, for example, I elevate them, I will be able to also modify the topography in situ of this terrain. Okay. Also, if we select the terrain, we can see here under this list area all the elevation data. So we can select all these curves individually. We can delete or remove them, so the terrain will be recalculated. We can also add a new contour. Actually, here I see that there is a kind of gap here. If I draw a line, let me do this from the top viewport. If I draw a line that I can use as a terrain contour, okay, now I can select the terrain. Maybe I can just go here and select this option, the add contour command, pick the terrain, select the contour, and now the terrain has been expanded to this new contour, as we appreciate if we put this back to 3D. Okay. Actually, there is a nice option to see the contours of the terrain projected on top of the topography. If we select the terrain and go to General and enable this option, show both 2D and 3D when the representation is 3D. I also would like to see more contours on this terrain, so we can select the terrain, go to contour lines, and now define the contour interval every 20 centimeters, for example. Okay. Something else that we can do, if we see this terrain from the top viewport, we can see that there is a gap here. And we have this boundary curve, and I will use to define the new boundary of the terrain. Actually, need to adjust this curve so it meets. I will do this in 2D representation. It's always better or I can do this afterwards. First, I will run the terrain boundary command first with this option here. So I select the terrain, I select this curve, and now as you can see, the terrain has fit into this curve. But now I will need to select it and stretch, the limits of this terrain so it also reaches the other part because the boundary curve that I used before is small. All right, so let's see how this looks like in 3D one more time. Cool. Also, there is an option to add a base to the terrain on a bottom cap if you like, but for now we'll leave it like this. What we could do now is to see some of the terrain operation tools. We will add a path on this terrain and see how the moving operations perform. So I'm gonna work back in 2D, and I will draw a path curve here that I will use as the terrain path. So I go to Home. I'm gonna draw it from a spline, and the terrain path could go something like this. Okay, this is actually now a curve in the zero elevation. This is something important to take into account because when we add a path on this terrain, the elevation of this curve would be one of the criteria to perform the operation inside this terrain. Okay, I will change to wireframe display mode, and now I go to the lens design. Under these cut and fill operations, we can see several options for creating terrain earth movements, and I will choose this path option. Now I need to select the terrain. Actually, we just need to follow instructions in the command line when you run any of these commands. It's pretty intuitive. The path will be 3 meters, and we need to select the slope angle by which the terrain will meet, the boundary of this terrain of this path along its curve. And 45 degrees is fine. And finally, I need to select a curve. And now, as you can see, the path has been applied on this terrain, taking the curve elevation as a reference. But now, if we select the terrain, we can see now this earth movement with earth moving option with one item. That means that there is just one operation that we have done here, and this is the path subdivision. By the way, since we have added an operation, we can already list it in this in a new table, in a new list. So here we have the terrain list option, and as you can see, we can display the amount of volume that has been subtracted from the original terrain. Okay, nothing has been added, everything has been subtracted. But let's see how this value changes as soon as we modify the slope of this path. So now I select the terrain. I can select this path subdivision and change the angle, but also if we go to the path tab, we can change the slope method. Okay, and now it's set to the curve elevation as we have seen, but we can change it to a specific grade. So we can maybe define a grade of 6 degrees. Okay, well, you can explore the different options. You will see here how these values update. Okay, the fill volume and the dig volume as well. And also maybe the best option just to create the less amount of earth moving is to choose this option where we can adjust the curve to the terrain elevation and then create the path from that position. Okay. Right. Also, there is an option. I mean, when we create this path, there is a subdivision also created on this area. And if we select the subdivision, we will be able to change the material. So we can go to the material tab and also pick one of the textures that we have available here. All right, so let's go back to the top viewport. Now I would like to show some more options for inserting plants. By the way, I would like to also list the area of this path in the zoning list, and there is an option to do that if we select the subdivision and we click on this zone icon. A new zone will be created, like terrain path, and this will be listed also in the zoning list. Okay, we can see here. Sometimes if it doesn't update automatically, you can just select this object and run this update icon in the edit panel. Cool. So as I was saying, I would like to insert more plants here. I will create a zone, a forest on this right side of the path, and I can use this forest command. Okay. Now I can select any of the species that we have in the model, like this one, and under the forest tab, I can select how I want to distribute them. Can be a random distribution or ordered distribution using an array option. Let's see first this option. I want to insert 50 units, separated 1 meter each, and click OK. And now I could either pick an inner point that will calculate the boundary area, or I can select this boundaries option, and then I can either pick an existing curve or draw it on the fly. I will choose this polyline option, where I can just define, through a polyline, the area of the forest. Okay, click enter when you're done. You don't really need to close it. So the forest now is created on this area. You can modify this area by pulling, the control points of this forest, and the plants will be distributed and also will be all projected on top of the terrain as well. Let's take a look at this forest in 3D, and you can see that the plants have been projected on top of the terrain. Some interesting options on this terrain, on this forest, for example, is the option to use this array distribution. They are all ordered. Maybe we'll appreciate that better in top view. Okay, and also in 2D. So yeah, there are several options to distribute the plants. And we can also combine species here. If we select here more than one element, we'll see that we have two species now hanging from one part or another. And then we can just browse in the plant database for a new species. For example, I will just look for a jacaranda and have here some nice jacarandas. Okay. Okay. Well, since we have inserted some plants, maybe we can add a list of these plants. So in a similar way we have done with the zones and the terrain, we have here the plant list. So we can insert this plant list. Okay, that will count the amount of plants for each species. Okay, so we have all these items. Actually, these all species is that one that we have inserted here. Imagine that we have this species in another position, like in these pots. Okay, so we'll just make a copy of these plants on these places. And now we can see here that we get 2 units, all right? But let's imagine that we want to list only the plants that are on the terrain, on top of the terrain. And we don't want to include those that are in that lower part of the park. There is an option in the plant list that lets us filter plants by region or by layer. Also, a different way to filter them would be organize these plants in different AutoCAD layers and then choose some layers and others to control the plants that are listed here. But now I will show the option to filter by region. So under the filters tab, we can enable this by region, select a boundary. I will pick this boundary. And as you can see, we only see now the plant species inside this boundary. So these two plants have been okay. Great. Let's move on. Maybe we can explore some of the other 2D documentation tools. For example, here we can find the level mark, which is a useful feature to know the elevation of the park in any specific spot. So actually, these level marks detect the elevation of the terrain at the bottom, and they show this well the the exact elevation. Okay. Also, we can measure the slope of, for example, this path. We can run the slope command, select an existing path, and then we'll see here this slope. Actually, this is measured from the start and the end point of this curve, but we can also select 2 points in the drawing using any of these options here on the command line. For example, the polyline, I want to measure the slope from this point to that other point. Okay, so you can measure the slopes from any points. And of course, if we stretch this, we'll see how the slope updates. Cool. Well, maybe we can see some of the civil work tools. Maybe we can insert urban furniture here. I will explore in the library, the block library, some of the objects that I can insert here. For example, we can select any of these double swing. Okay, I will insert it in this playground area, right? And well, this way we can populate very quickly the project with desired blocks. Actually, Line Design provides a library of urban furniture, but if you have any 3D blocks that are compatible with AutoCAD, you can just use them too for your project. Okay. All right. Just to finish, I would like to show you some of the animation tools. When you launch Line Design, you can find this animation panel where you can define the settings for creating a quick animation. Okay, and you can do this by defining a camera path and while setting the other animation settings. So basically, I will use this curve that I used before for creating a camera path. I will use the realistic display mode. Also, I will choose the 3D. Maybe I can select the original curve. Let me see if I can select it if I choose the wireframe. Okay, what I will do first, since I have this curve in the ground, okay, I will elevate it to the terrain. I will just go to here to adjust option to the terrain. And now I can select it again. We'll change this to realistic one more time. And I will move it a little bit up. I will elevate it 1.50 meters. Now, so under the animation tab, we can click on this path button. We select this curve. And we can define here now the animation settings. For example, the total frames per second or the total duration of it. And if we click on this render button, we'll generate an animation, a video file with a render for each frame of this animation. But we can just have a preview of this animation with this play button. And in this way, we can evaluate if this animation is suitable for the result that we want to present. Actually, there is also a nice option to navigate through the project, which is the walk mode. So here we have this option where the program puts us on top of the terrain, and just with the cursor, we can just move over the project. We can change the speed, we can move the mouse pointer to see one direction or another, and also navigate through the project in a kind of an interesting way. All right, so this is pretty much the end of the presentation. Remember that everything that has to do with presenting the 2D drawings, it's pretty much what AutoCAD handles on its own. So you can work in page layouts, show the 2D drawing, show here different views of the model space to show maybe elevations, plans, schedules, and in different views. And well, since we can control the 2D representation or the different display modes in each view, you can have a nice layout with all the necessary documentation to present the project. Elham, let me know if the people have any questions so we
Yeah,
can
yeah,
see some
that's
of
the
them.
time. There are a few questions about ZWCAD. This is something that we constantly are hearing about ZW users. So we are working on internally, we are working to develop a suitable version for ZWCAD, but well, it is on the way. So we cannot promise right now, but so far it is promising. I'm going to also, there are some questions about the specification of the system. Whatever specification that you have for AutoCAD must work for Lens Design too. But I just wrote it down in the chat, so you can take a look at it or copy that. So as you see, Lens Design is a plugin, so it's from the same product group of Rhino Lens. You can find it in rhinolens.com at the moment. We are working to have a new website for lensdesign.com, but right now it is in rhinolens.com in download page, and you can select the product Lens Design for AutoCAD, which is the version that we saw right now, and download it. About system requirement, also you can find the information again here and download the program. And of course, yeah, another question is about the language. It is available in 7 languages, including German, French, Chinese, in some other languages. Okay, there's a question about irrigation system work. How we can, if we can show that.
Yeah, I can show very
the-
quickly some of the irrigation tool features.
Yeah.
So based on this project, I will move to 2D and show it in 2D representations. Imagine that we want to irrigate this area where we have the ground covers. So, well, here we can create a sprinkler array. You can insert sprinklers individually or through an array. And if we choose the array option, we can select the sprinkler type. Okay, there is also a few options for the symbol, and under the array we can define also the distribution option and the distance between the sprinklers. So we select now a boundary.
Great. Yeah. Then once we insert the sprinklers, also we can ungroup them if we want to remove or to rotate one of them, for example. So you select that sprinkler matrix or sprinkler array, and we can ungroup them from edit panel. Yeah, there. In case that, for example, one sprinkler is irrigating out of the bed, the plant bed. Yeah, that's great. And then, yeah, the pipe, the pipe works
Yeah, pipe
like
basically
dry.
can link
Mhm,
sprinklers, or
mhm.
well, you can just yeah, click on new, and then we can just click on the sprinklers to connect them.
Yeah, another question is, can we place manually the each sprinkler? Yeah, that's the another tool. You see that there's a sprinkler array, and another tool in the menu, you see that it's a sprinkler. So if you want to insert them
Yeah, you can also
individually, yeah,
insert individual sprinkler, place it
yeah, exactly. For the
here.
corners, for wherever you need to place them individually. So how
This
to,
is
yeah,
the
place the
pipe
pipes.
object is it's just a line, but it contains some information. So later on, you can list this information as well. Here under the
Mhm.
listing commands, we can also list sprinklers and pipes with the total linear meters of them, and this information that is assigned to this 2D line. And we can also insert a sprinkler list.
Mm.
Yeah.
Okay. Any other questions? Okay, so thank you everybody for joining this session, and I hope you can enjoy the 60-day free trial of the program, try it out by yourself, and let us to have your feedback. Have a nice day or a nice afternoon.
Thank you for attending this webinar.